What's going on, guys? So today, the topic that we were learning about was molar mass. So let's just kind of roll through. These were the notes that were given. Molar mass, mass of 1 mole of an element or compound. So the atomic mass is expressed in grams found on the periodic table. So the way to get that number is from a mole's worth, or Avogadro's number, worth of those atoms of that element. 6.02 times 10 to the 23rd of them is equivalent to 1 mole, right? Just like a dozen, right? Instead of saying 1 mole equals 6.02 times 10 to the 23rd atoms of it, that'd be like the same as saying, oh, 1 dozen is 12, whatever, right? It's a count, it's a measure. And then they take that and mass it. So if I said, hey, I have a dozen carbon atoms, it's 12.01 grams. If I had a dozen oxygen atoms, it's roughly 16 grams per mole. Molar mass, sometimes talked of as atomic mass units. We express it in grams. So the periodic table that I gave out today, you will see where that is. So I'll show it to you real quickly. So on this periodic table, boom, where it says average mass, okay, that is where we're looking for, and that will be the mass in grams per 1 mole of that element. So for silver, we got on our periodic table that I gave today, it's 107.87. For carbon, it's 12.01. For sulfur, it's 32.07 grams per 1 mole of it. So you would look for potassium, K, tin, and lead. All right, so we have potassium, tin, and lead. So if we looked potassium K, we would say it's 39.01. Tin and lead. So tin, 118.71 grams per mole. Lead, 207.20 grams per mole. Then we get into the molar mass of a compound. So with this, it's the sum of the total molar masses of all the elements in there and how many of them there are. Oh, let's go back. So this guy here, we calculating the molar mass of CaCl2. So how I do this is I make a little table. I don't throw the border around or anything like that. I just write it as E hashtag M for mass, and then you are going to multiply the number of them times the mass. So if I wrote this guy out here, if I showed an example of that, of CaCl2, let me do this. Let's go up top and let's rotate the screen. Okay, so that's how I write it. Molar mass of CaCl2. You take the element, you write them out. All right, so here CaCl2. All right, first element you see is calcium. How many are there? There is no subscript after it, so it's just 1. The chlorine, all right, you write Cl. There are 2 of them. And then on your periodic table, you're going to look up the masses. So the periodic table that we're given, Baum. All right, let's see. We're looking for Ca, so it should be over here. 40.08. And then chlorine, somewhere over here. 35.45. Then, once you do that, or once you get that, you just multiply them together, right? Multiply across, get those numbers, values, add them together, and then your final answer, if they're asking for molar mass, it is that many grams per mole of calcium chloride. All right, in another example, we used potassium phosphate. So for the potassium phosphate, K3PO4, okay, simple enough. Element, number, molar mass. First element, potassium, K. How many? 3. Next element, phosphorus, P. There's only one. Next element, oxygen. There are 4. Find their masses from the periodic table. Multiply the number times the mass, right? The number of each element in there times their molar mass. Get them and add them together, and that'll be your grams per mole of said compound. Next thing. So if you were looking for the molar mass of a compound containing multiples of a polyatomic ion, how do you know if there's multiples? Your polyatomic ion is going to be in parentheses, right? Like here, NH4 with a subscript 2 after the parentheses, and then CO3. So what happens, guys, is the subscript outside your parentheses distributes to everybody inside. So this 2, all right, normally there's only 1 nitrogen and 4 hydrogen, but there's a 2 here, so everything would double. So that we would have 2 N's and 8 hydrogens, 1 carbon, 3 oxygen. So it should look like that. Okay, same thing applies. You would write E, hashtag M, write everybody out, get their masses, add them all together. This one should have been a total of 96.11 grams per mole of ammonium carbonate. Okay. Then, after we've gone through copying down the notes and dealing with that, we got into our assignment. Let's do this, sorry. All right, very simple. They want to know what the molar mass is for the following elements. So 1 mole of an element, atomic mass of an element in grams found in the periodic table. So in 1 mole, so we're looking at the first dude, calcium. Find calcium in here. It would be 40.08 grams per 1 mole of calcium. That's it. For section 1, that's all you need to do. Now for section 2, you're doing exactly how I showed it, all right, in the notes there and the examples up on the board. If we were to complete this guy here, the Al2SO4 3, all right, so if I do that, element, number, mass, first element I come across is the aluminum. How many are there? 2. Okay, next is S. Now, it's polyatomic ion, the SO4, and there's 3 of them, so the 3 distributes. So normally there would only be 1 S, but the parenthesis on the outside multiplies it. So 1 times 3 is going to give me 3. And then the oxygen, 4 inside, 3 outside. The 3 distributes, so it would be 3 times 4. There are 12. And then from there, we're going to look up everybody's mass. Aluminum, here we have our 26.98. Sulfur, 32.07, and oxygen as 16. So we got to write those guys out. 26.98, 32.07, and 16. And you multiply the number of each times the mass of each. 53.96. Next one should be 96.21 and a 192. Add all of them together, and you are going to get 342.17. Now this is grams per mole of the compound Al2, SO4, 3. So aluminum sulfate. All right. Now, that is going to be what you need to do for section 2. For section 3, determine the mass of these following samples. So the number of moles times the molar mass of each element. So I didn't quite show this in class today. I will kind of show it tomorrow. It's a little flow chart for stoichiometry, which we're going to be getting into tomorrow. This kind of helps navigate us to where we need to go. So what are we starting in? We're starting in moles of something. And what do we want? We want mass. So to go from moles to mass, okay, you need to do a conversion. The molar mass of the element or compound over 1 mole. So, for example, if we were to look at the first guy here, 2 moles of cobalt. All right, well, you would do, as the chart tells us, we want to go from moles to mass of something. So you would do, write what you're given, put it in our little starting position. 2 moles of cobalt. And then conversion says the conversion factor here would be the molar mass of cobalt over 1 mole of that. So the molar mass of cobalt, we looked that up, periodic table, 58.93. So there are 58.93 grams of cobalt in 1 mole. That's like that grams per mole thing here. Okay, it's just an easier way to write it out. But for this and for future problems, this is going to be kind of the formula or the setup that we need to get to. So 1 mole of cobalt. So that way, moles of cobalt cancel. All right, you need 1 unit on top, 1 on bottom for it to cancel. They need to be the same. So by doing that, okay, and then we multiply everything on top and divide by what's on bottom. So this is going to come out to be 117.86, and the only unit left is this, grams of cobalt. Easy enough. Okay, but what happens when it's just not one element and we have a compound like H2O? All right, well, what we need to do here is we need to know, again, the conversion factor says we have to do moles given to the mass, right? We want to go from moles to mass, so the molar mass needs to be on top. So we need the molar mass of H2O. All right, so I would say let's do, it's kind of like a little two-stepper. Element, number, mass. First element we see is hydrogen. There are 2 of them. The next element we see is oxygen. There are 1. Looking on the periodic table, hydrogen, the one periodic table that I gave you guys, that's what we're using, 1.01, and oxygen, 16. You multiply the number times the masses, 2.02 and 16, add them together, we get an 18.02. All right, that is grams per mole of H2O. Okay, so I needed to do that first. Once I know what the molar mass is, now, moles given, moles of H2O. In 1 mole of water, H2O, we figured that it has a mass of 18.02 grams. So, moles on top, moles on bottom, cancel, and we multiply across, and we come out with 54 point whatever. We rounded to 2 decimals, and then it would be grams of our element or compound. Bam. So that is your third section here. Now the fourth section. The fourth section is going from grams to moles. Grams to moles. So to go from grams to moles, you need to take the number of grams that were given, then do 1 mole of that, all right, element or compound over its molar mass. All right, also shown here in the roadmap, they gave us a certain mass. Okay, we need to multiply that. You put it in the starting position, and then this little bracket goes up. Okay, 1 mole of that substance over its molar mass. So if we were to do this for N2, so I need to know the molar mass of N2. Well, look on my periodic table. Nitrogen, there's 2 of them. The molar mass of that guy is 14.01. And then you need to multiply them together. All right, you should get a 28.02 grams per mole of N2. Now that we know its molar mass, we can go and do, all right, our step. Take the mass given, that goes in the starting spot. So we're going to get 54.2 grams of N2. And then our conversion factor would be 1 mole of N2 over the molar mass. So in 1 mole of N2, we figured out that it was 28.02 grams of N2. Grams of N2 on top. On bottom, cancel. Multiply everybody on top and divide by what's on bottom. And we're going to come out to be roughly 1.93. And the unit left is this guy here, moles of N2. Okay, so that is how we complete the assignment today. You guys will finish sections 1, 2, 3, 4. Don't worry about the bottom section here, where it's saying determine how many atoms or molecules of anything there are. All right, hope that helps.